Hey guys, welcome to my YouTube channel. So in the last lecture what we see is that we have seen the energy that is possessed by the electron at different orbit of energy. So the direct simplified formula that we get is that minus 13.6 divided by n square EV. This is the thing that we get. So n is the principal quantum number. So n is the quantized number, will be simply stating that one. So principal quantized number. So this thing, you know how we get it. So instead of directly getting into, everyone knows this formula, but we have detailedly gone through how this formula came in the previous lecture. So let's take how this in a real term, how it will come. So let's take an energy levels, different energy level. So this is n is equal to infinity, this is n is equal to 2, then this is n is equal to 1. Okay, so let's state it the name n is equal to 1, n which is equal to 2, then n is equal to infinity. So we know that when we substitute infinity here, the energy will be 0 ev. Okay, so when n is equal to 1, the energy level here will be minus 13.6 ev. So when here, then energy level will be 13.6 divided by 4, that means 2 square ev. So this is how the energy at each level it will be presenting. So this is discrete energy levels, not the same energies can be. So every energy levels will be discrete. So that is what another one important key thing we need to remember. So these are discrete energy levels. So what will happen if two atoms came into interaction? Then how these energy band levels will split, or how that would react. So that thing let's see here. So let's take the simple hydrogen atom here. So hydrogen atom. So we know that there is only one electron. So that will be present at the energy is equal to that energy. So let's take here. So here the n is equal to 1. So electron is presented in this level. So if the another one hydrogen atom is present here, though there also some one electron will be presenting here. So this is here. So the distance between the two things is very far. So there is no interaction. So this is far away. So far away. So no interaction. So then no theories will come into play here. Like if two things are separate, then it will act in its own life, it will act in its own life. So there is no interaction, no nothing is be there. So it will have the energy state, one energy state, and this will have one energy state. That will be one energy state, this will be one energy state. The energy will be just 13.6 because this is only n is equal to 1. This is also n is equal to 1, 13.6. So then the game changes when both are came into interaction. Like for an example, if both are coming into interaction, then what will happen? The electron one will attract the another one electron, or it will repel, or anything, any behavior it will do. So there is some kind of behavior will take place if there is of state of act that. So let's take the energy levels. So this is the energy level that we will be having. So this is one. So let's take this as a distance. Let's take this as a energy at EV, its unit. So last class itself we discussed this diagram. So here both are at a far distance, so no interaction, nothing will be there. This is far away. The distance is far away. If both are came into interaction, so this zone, from this zone there is an interaction zone. Then what will happen? According to Bohr's theory, not two states can be at the same energy level, that need to be discretized. So there will be a concept of splitting of energy level. So this is one important terminology we need to understand. There will be a splitting of energy level. Here you see both are at the same energy level. The change will not be much. For sake of understanding, I am drawing in a this much distance. So the electron at one hydrogen, at electron at another hydrogen will be at the different state. So this state is called splitting of energy level. This is one important terminology that we need to understand. So why and when the splitting of energy band will take place? I think this clearly gives an understanding how the splitting of energy level will take place. So let's take another one terminology where there is n number of hydrogen atom are coming into picture. So when they are at a far distance, nothing will happen. Everything will be staying at thing. So for example, n hydrogen are coming into interaction. N hydrogen atoms. So after this state, what will happen? Energy splitting will take place. So n number of energy levels will be splitted based on number of hydrogen atoms it's presenting. So this is the group of energy level for this particular. If the combined thing will be called as one substance, right? So that is what they are mentioning a group of energy level. Group of energy levels, or the simple or famous term is called bands. So usually we won't say as energy level, we bands. So why the band came into picture here is because of this splitting. So this will be 13.6 only, minus 13.6 only. This change will not be also be huge, but because of the Bohr's and other theories, the different atoms cannot possess same energy level. So they are splitting into different things. So this is distance, then that is energy level E. Okay, I think this gives a good physical significance of how the band is created from the energy level. So let's revise what we see here. So last class we discussed about the energy possessed by the electron at a different orbit. So from that we are simply making the atomic energy diagram for different energy level. After that we are coming into interaction between two atoms. If there is a far distance, there is no interaction, so nothing will work. If there is an interaction, there will be an according to Bohr's principle, the two energy levels cannot be possess same energy, so there will be splitting of energy levels. If n atoms are coming into combine, then that will be called as a group of energy level or bands. I think this giving you a clear understanding. If there is any doubt, please ping in the comment section. Like, share and subscribe the channel. Thank you. Let's see in the next lecture.